So now we're going to talk about two variable linear systems. And what that means, if we have two variable linear systems, what we're going to have here is we'll have ax plus by is equal to maybe k1, and then cx plus dy is equal to k2. So that's going to be a general form of our linear systems. And the key thing is, why are they linear? Is, well, the exponents on both the variables are 1, and if you think about the graphs, again, what are these? These are going to be straight lines. And so that's why these are linear systems. So we're going to be looking at two variable linear systems. Now, you can still solve these using the substitution method, but there is another method, and that's what we're going to focus on in this video. The substitution method, we did actually examples that, and quite frankly, were more challenging. What we're going to do is called the method of elimination. And the goal here is to add both equations together and have one of the variables cancel out. And then a star here. It may be necessary to first multiply one or both equations by non-zero numbers before adding. Okay, so that might be necessary to do. Alright, well, let's just look at a real simple example to start with here. And the example we'll start with here is we're going to have the system of equations 2x plus y equals 4, then 2x minus y equals negative 1. And now, when I do these problems, I often don't write the curly braces down when I'm working them. So what I would have maybe is 2x plus y equals 4, and then 2x minus y equals negative 1. And then I even sometimes, it's not necessary to do this, but I even sometimes kind of just say, okay, I'm going to add these together. Now, before I just add them together here, we want to make sure that one of the variables cancels out. But if you notice here, I have plus y and a minus y. So if I have y plus a negative y, those of course are going to cancel out, and I'd just be left with x's. So let's see what we'd have. We have 2x plus 2x, which is 4x. And then I'll go ahead and write it this time. Y plus negative y, which would be 0 times y. And of course, we wouldn't write 0 times y generally. We would just write nothing there. And then I have 4 plus negative 1, which is 3. And so you have 4x is equal to 3, and x is equal to 3 over 4. Now, just like we had to do before, we have to figure out what y is, and so we have to substitute that. Now, we can use either equation. I'm going to use the top one. Maybe why don't you guys try the bottom one and see if you get the same answer as I do, because you should, because this is, again, if you're thinking about the graph, this is where they intersect. Okay, so what do we have here? Well, I'm going to use the top equation, so I have 2 times 3/4 plus y equals 4. So this would be 3/2 plus y equals 4. So y would be 8/2 minus 3/2, which is just 5/2. And hopefully when you do the other one, you should get the same answer. And you do. If you don't, that means you've made a mistake. And so what would we get here? Solution is 3/4 5/2. Now, before we look at any other examples here, let's go ahead and talk about the graphs and the nature of what these solutions look like. So let me pull in a couple graphs here. I don't care if they're perfect at this point. That one's going a little off the video capture, but that's okay. Alright, so we know that these equations, again, that we're looking at are straight lines. So a very common one to think about is, okay, well, you have a straight line here, and then draw another straight line that has a different slope. Maybe it has positive slope as well, but okay, let's say it looks like this. So if you solve this system of equations, there is one solution here. Because there's only one intersection. Now, if we think about that, that's going to be in general true. If you have two lines, typically you're going to have just one intersection. And you can't have two lines that have two intersections. Well, I'll be careful. Technically, you could have two lines that intersect twice, but if they intersect twice, they're actually going to intersect at every single point. In other words, they're going to be the same line. So what else could we have here? Well, we've talked about, remember, parallel lines. So if you had parallel lines, they might look something like this. And what do we know about parallel lines? They never intersect. So if you have parallel lines that are represented in your equation, you have no solution. And then the last case, which is one that's not as obvious, is if it's called the same line. So if I draw a line here, that's my first equation. And then my second equation might look different, but then if you actually were to simplify it all out or do something else, it turns to be the exact same equation. So they're literally lying on top of each other. So they don't intersect at one point, they intersect at all their points because they're the same line. So this would be infinite solutions. So those are the three cases that we can encounter here. So let's look at a couple more examples here and solve some more systems of equations, and keep in mind that we might have, our three options are one solution, no solution, or infinite solutions. Alright, so let's look at another system here. Let's look at the system 2x thing again here. 2x plus 3y equals 17, and then 5x minus y equals 17. Now, if I were to add these together as is, none of the variables would cancel, because I'd have 2 plus 5, which is 7, 3 plus negative 1, which is 2. So I'm going to need to multiply one or both of these equations by a constant. Now, if we don't think about it for too long, we can see that if I take the second equation and multiply the second equation by 3, well then I'd have a minus 3y, and I'd have 3y minus 3y. So let's go ahead and do that. So my first equation doesn't change. It's still 2x plus 3y equals 17. And then the next equation, though, is 15x minus 3y. Now you have to be careful, make sure to multiply everything by 3. So I need to do 17 times 3, and my arithmetic is failing me right now, so I'm going to just make sure on my calculator, and you get 51. Now let's go ahead and add these two equations together. So if I add those two equations together, you have 2 plus 15, which is 17x, 3y minus 3y, which of course cancels out, and then this is equal to 17 plus 51 would be 68. And then to solve for x, we of course would just divide both sides by 17, and we get x is equal to 4. Now again, we can pick either equation here to find what the y value is. I would probably pick this one, not because it's that much easier, but I have a number 1 in front of the y, so that's why I'm thinking, oh, even though it's negative, it's just a 1. And so I would have 5 times 4 minus y is equal to 17. And so you have 20 minus y equals 17, which would get me 3 for y. Adding y to both sides and subtracting 17, we get y equals 3. And so the solution is 4, 3. So not too much more difficult than the first one. The only thing we had to do is we actually had to multiply one equation by something. Okay, so let's look at an example here where we have decimal numbers. People tend to not like decimal numbers, and it's too bad. I don't think decimal numbers are that bad, but we can also make these so that it's not that bad at all. So we have 0.03x plus 0.04y is equal to 0.75. And then 0.02x plus 0.06y equals 0.90. Now, most of us don't like to work with decimal numbers, so let's not work with decimal numbers. What's the decimal place that's the farthest out? Well, this is the 10th spot, and this is the 100th. So I've got decimals that go all the way out to the hundredths. So I'm going to multiply the top equation by 100, and then I'm going to multiply the bottom equation by 100. Now if I do that, what do I get? Well, 0.03 times 100 is just going to be 3x. So I'm going to have 3x plus 4y, and then 0.75 times 100 is 75. And then the second equation would be 2x plus 6y is equal to 90. So I've got it where I now have no decimals. Now I'm going to do the elimination method. Problem is, if I add both equations here, I'm not going to cancel out a variable. Now, one thing you can do here as a general rule, if you can't see what it is just take, since these are both positive, I'm going to have one negative, but just take this number here, which is 2, multiply that to the top equation, and then this number here, which is 3, multiply it to the bottom equation. Now I'm going to do negative 3 because I want them to be opposite signs. So what do I get for the top equation? The top equation, I'd get 6x plus 8y is equal to 150. Alright, and then I'd have negative 6x minus 18y is equal to negative 270. But now I can add these equations together, and if I add the equations together, I get negative 10y is equal to, well, 150 minus 270. I think it's just negative 80, but I, again, not trusting my arithmetic right now. And there's a good reason I'm not trusting it, because it's not 80 at all. It's negative 120. Some days my arithmetic is just not as good as other days. And then I'm going to divide both sides by negative 10, of course, and I get y is equal to 12. So we really didn't even work with the decimal numbers. Now I, of course, still have to find x. Now you could use one of these two equations up here to find x, but as long as what we did was correct, which we are, there's no reason to not just use one of these two equations. So again, I don't have to use decimal numbers. So I'll just use the top one. So I'd have 3 times x plus 4 times 12 is equal to 75. This should be a plus. There we go. So then I have 3x plus 48 equals 75. And then 3x would be 75 minus 48, which is 27. Divide both sides by 3. And then x is equal to 9. So the solution is 9, 12. Now I'm going to go over one more example here, an example where we get no solution, and then I'll just talk about what would be different if you had infinite solutions instead. So let's look at this example. So let's look at 6x minus 5y equals 3 and negative 12x plus 10y is equal to 5. Okay, so I want to, again, use my elimination method. Well, I can see I'm going to have to multiply the equation by something here. Well, I can see if I multiply this top equation by 2, I'm going to have a negative 12 and a positive 12. So let's go ahead and multiply my top equation by 2. So then it's going to be 12x minus 10y is equal to 6. And then we've got negative 12x plus 10y is equal to 5. So then we go ahead and add. Well, I have 12 minus 12, which is 0, okay. But then I have negative 10 plus 10, which is 0. So I get 0 is equal to 11. Now notice the variables have all dropped out. There's no variables on the left-hand side, and I'm left with a statement that's not true. So clearly 0 does not equal 11. So what this means is there is no solution. And instead of maybe talking about it, let's go ahead and do one more example of what would be the case if you got an infinite number of solutions. The variable is going to drop out still, we'll notice here. So let's look at this one here. 1/2 x minus 1/8 y is equal to negative 3/8. Okay, well, and I suppose I should give us another equation here. We also have negative 4x plus y is equal to 3. Okay, so let's go ahead and look at this. Well, first off, there's fractions. I don't like fractions. So let's multiply by 8 to get rid of all my fractions. So if I multiply through by 8, the top equation would become 4x minus y equals negative 3. Then my bottom equation is negative 4x plus y equals 3. Now, I'm going to do my elimination, so I'm going to add the equations, and notice I have 4 minus 4, so it's going to be 0. So I've got 0x, but then I have y, negative y plus y, which is still 0. So I have 0 on the left-hand side, negative 3 plus 3, which is 0. So the variables have dropped out, and I have 0 equals 0, which 0 does equal 0. So that means this has infinite solutions. Now there is a way to write those solutions down using what's called parametric equations, but that's something beyond the scope of this class. It's just a way to write an infinite number of solutions down. Alright, so that wraps up this. The next video we're going to actually talk about systems of equations that have more than 2 variables. They'll still be linear, but we're going to have more than 2 variables. And we'll see fairly quickly that we're going to want to come up with another method